Okay. All right. For people joining the live stream, this is a continuing discussion about incremental language development for Wolfram Language. And we have a variety of topics today. Okay. Ascending and descending order sorting for sort by.
We have Carlo today here for this discussion.
Hello.
Hi. Any is applied to each element of the list. Okay. All right. What is the issue here? Is the issue some kind of correspondence with database sorting or what?
No. Okay. So we talked about this maybe a year and something ago. And the point is that, well, databases establish a precedent, but I think this is useful in general for the language. So sometimes you want to sort by different functions, having a tie break, but the functions are, for example, not all numerical. So one of them could be, you sort by, you remove the first two characters of the string and then you sort by that, but you want reverse order.
I see. So it's a sort by. I mean, in other words, if it was just numbers, you just put a minus sign in front. Right?
Exactly. And that's often what you do.
But so.
There are two related important things here. One is that we have recently introduced reverse sort and reverse sort by. Mm-hmm. And the second is the third element of sort by that takes an ordering function.
Okay, so why isn't the ordering function just the third element? Wait a minute.
We don't have a notion of given an ordering function, say numerical sort or numerical order or alphabetic order, how to reverse it. And I think that's what
I understand. So wait a minute. The function p to oh, I see. That's the ordering. So that would be, so if that third element there was a reversed, so we'd say sort by list F and then some kind of reverser. What would that reverser be? Is that reverse? That's what you're proposing, reverse order?
Well, I think Carlo is proposing to reverse the function itself, which I don't really understand. I would reverse the ordering function.
Okay, so the reason why I'm proposing that is that, I mean, at least in the case for databases, we have already used the third argument for the for limiting the result. So we want the first two or the last two. Now the problem with the ordering function is that the ordering functions don't really apply to SQL. You have only one lexicographic order. You can have collations.
Okay, I don't care what happens in SQL.
Yeah,
we're going to figure out that bridge later.
But the point is that what do you do if basically what you want is just lexicographic order but reversed? Like you don't really need to specify alphabetic or numerical or whatever.
I didn't understand that comment. I mean, to my mind, look, we have the notion of if I say sort by, and I've got, well, here, so I say sort by this, comma, and then I say identity. And then what is this ordering function? Is it something where I can say minus order of hash? What will that do? Yeah, it'll do that, right?
Yes.
Whereas if I say plus that, then it'll be in that order, right?
Yep.
Okay. So this minus order thing, or alternatively, I could write this, could I not? Is this correct?
That's the default, yeah.
No, I understand that. But I mean, in other words, so another way to do this, if we had a function reverse order that was simply the same as order, but with reverse signs.
Right. Does this work for a list of functions in the second and third argument as well? Because it's not documented.
Not yet. So right now we only have one single ordering function common to all the.
Because that's the case. I mean, the case where you just reverse the common order, that's the reverse sort. So it's not terribly interesting. The point is that you might want one in one direction, one in the other. That's where it becomes interesting, and that's where I also think it becomes kind of ungainly to keep track of 5 different functions in the second and 5 in the second in the third argument.
So this is a discussion we had when adding this third element. We are planning to add a list in the third element and then having respective ordering functions. The alternative idea was to use a list of rules in the second argument, but I think it was Jeremy who pointed out that that syntax is already meaningful now.
What does it mean?
Or could be nothing, but in principle, we can put anything we want in the second argument. So why not rules if somebody wanted to do that for some reason?
Because rules, well, okay, fine. I mean, that seems obscure.
Mm-hmm.
Seems a bit pedantic, to be fair. I mean, one can document an exception to that rule.
Yeah.
Hey, Devin, could you screen capture that autocomplete, which is absolutely absurd?
Yeah.
And find out why the reverse bi-orthogonal spline wavelet occurs in third place there.
Yep.
Okay. That's one of those things about which we should just be silent here. Anyway, never mind. Okay, go ahead.
So I think that there are two different things here. One is whether this additional mark we need should be in the ordering function or the function itself, which I'm more or less convinced it should be in the ordering function, and then how to represent it, whether we need the third argument or the second argument.
Well, okay, so what does this semantically mean? What would this mean? What would this return? If I apply that function to something, what on earth does it return? I mean, let's say that there's an alphabetic. Okay, so alphabetic order. Where do I put that? If I want to sort by alphabetically, what do I do?
It would have to go into the third argument of sort by or the second of sort.
I see. It's the comparison function.
Exactly.
I just wanted to add another thing to this thing that Jeremy pointed out, and it's that lexicographic ordering burrs into symbolic wrappers. So if you have something that doesn't have evaluation semantics in the second argument of sort by, you get exactly the same order. So if you do sort by F, is the same as doing sort by identity, if F doesn't have the initials.
Mm-hmm.
But Carlo, do you agree that F in the second argument is the function producing strings, and then alphabetic order is the comparison function that goes in the third argument?
No, yeah, I understand that. What I'm saying is an argument for having a rule. It's much simpler to type, and it's much simpler to keep track of, because in general, I mean, at least what we've seen is that in most use cases you have, say, 4 ordering functions. It's one case where you need to specify a reverse order, and so the fact that you have to write basically a constant array of order and then put in the middle a reverse order to achieve something that could be achieved with a much shorter syntax, because rule in theory could be used, but rule doesn't have evaluation semantics. So
I understand. Okay, so this question about whether it's okay, so reverse order in this form is just a negation of the order function. So that's fairly straightforward. So what you're proposing, a potential proposal would be that the form, that this is the usual form, and that is an alternate form, and that if there are multiple things with tiebreakers, you say, F reverse order, G order.
Or just G at this point.
Yeah, that could just be G.
Yeah.
I mean, that's kind of nice. I think that's now.
There is another advantage, that is that it can be used in the operator form of sort by.
That is a very good advantage.
And the other thing we could do is to keep the third argument and document it as the default. So if you don't put a rule, then you get what you had in the third argument.
That's also very reasonable. Yeah, right. So that then is an elision of everything is reversed. You just put it as a third argument.
Now, I don't think this is enough, because imagine that we are dealing with numerical order, and we are
Hold on. There's another form that we could have here.
Yeah.
We could also have FG arrow reverse order.
Right.
But go on. What were you going to say about numerical sorting?
Yes. So here we have order, canonical order, and reverse canonical order.
Mm-hmm.
But imagine that we are dealing with numerical order and it's reversed.
Yeah, I think one thing is the direction and another thing is the order or comparison function.
Right. So somehow we need an order reversed wrapper around ordering functions.
Which technically is minus, because reverse order functions return plus or minus.
Or true or false.
They do?
Yeah.
What returns true or false?
I mean, ordering functions or comparison functions.
That's ordered, right?
Yes, but it's documented to be accepted as well. So ordering functions can return either true or false, or +1, 0, -1.
So ordered Q returns true or false.
Yes, and it can be placed in the second argument of sort as well.
And that comes back to my original proposal of having something that maybe it should be. So if we had the function that is like reverse order or whatever, that could, when wrapped around. So I don't know what happens if what comes first, minus true or minus false. If that doesn't reverse the order, then you want something that is lexicographically reversing the order.
I'm confused by all of this. I mean, first of all, it certainly can't be called reverse order, because reverse order would be, so what the heck is this thing? Okay, so what it's doing, what is this doing? I mean, I understand what this is doing, what this reverse order thing is doing, but what you're saying is,
yeah, so what I'm saying is we need a function, let's call it reversed order or order reversed, that takes an ordering function and then 2 arguments, and then it's like reversing those 2 arguments. So it would be a very simple definition. It would be reversed.
Okay, so
reversed.
You're saying that this will return is effectively minus. That has
it will be order of BA. Yeah, so if you change order by P, we typically call these ordering functions P. So it will be reversed of P of AB colon equals P of BA. Exactly.
So this is like, I mean, it doesn't need to be just for ordering functions. We could have this work for any bar function. It's just
sure.
Yeah, swaps, like not just swaps, but changes the first to the last and so on.
In a sense, this is carry of P.
Is it?
It is, but of course it doesn't read well in the ordering world.
That would be so frigging obscure.
Right.
But now, in the case of curry of ABC, whoops, that's just going to be that. That just peels off one piece. So the general case.
We would have to use permutations. Carry of P 3 to 1.
Yeah, I understand. But reversed could perfectly well go to P of CBA. Right?
Yep.
Maybe argument reverse.
That's hopeless. Think about what the code is going to read like.
I mean, the other option is to have what I was proposing is to have something which is kind of a universal minus for lexicographic order.
No, it doesn't have a.
Because
look,
that's something that
evaluate to anything. It's some kind of weird thing which is going to hang out there as kind of an indicator. It's not. It's much cleaner if it can actually evaluate, because that way you can write code.
Yeah, but I mean, if you have reversed of the f of a, and that means reverse of f of a. I mean, is it?
Well, what are you talking about? I mean, look. Look. This. Okay, if we did it this way, then what this would look like is reversed of f, comma g.
No, exactly. No, I mean, this is what I was proposing, and it's not what.
Yeah. It is exactly right.
No, because f is not a comparison function. F is a by function.
Oh,
and
I see.
So if you want to write reverse that way, then you have to say that reverse of f, close square bracket, a, open square bracket, is reversed of f of a, and that reversed has a special meaning in lexicographic order.
But that doesn't work, Carlo. So what Stephen should write here is f goes to reverse order.
Wait a minute. Reverse order. Wait a minute. We're not having two things.
No. But what I'm saying, what we discussed at the end of your notebook is having here f arrow reversed bracket order, and that works.
Sorry, f arrow what?
F arrow reversed bracket order bracket. Exactly, and then comma g goes to order. So that would work.
Because in that way you can have alphabetical order, numerical order, any order function there inside the reverse. Right.
It's kind of interesting. It's kind of interesting use of functional programming constructs. I mean, clearly we can have an illusion that reverse order is the same as reversed of order if we care about that.
Yep. If we want to introduce both, yeah. Now,
is reversed the right name? I mean, it's clearly got to be something like reversed. But is that exactly the right ending?
I think if we want to use it in other places, reversed sounds good.
Well, but let's just walk through what it would actually say. So it would say, reversed of f represents a version of f which takes its arguments in reverse order. By the way, where am I storing this ILD material, Devin?
I could give you the cop-out answer, which is in the miscellaneous folder. But I'm unsure of another place to store it.
All right. We perhaps should have a section here called ILD. What do you think?
Yeah, so I was thinking something like ILD or like functional programming or something.
Well, have we had enough stuff for functional programming?
Not sure what else is in that miscellaneous folder. Well, I guess it's right there. Yeah, probably
not. Like head map and so on. All right, let's put this here. So reversed 01. Okay. Okay, again, part of speech question. It's not the F that is reversed. Okay, so other possible things would be reversal of F, reversing. I don't know if those help. I don't think those help.
When we were designing carry, we had two functions for some time, and one of them was called carry swap, I think, that was doing precisely this. And Roman wrote to me recently saying that the proper name for this in the computer science community is carry C.
Carry
capital,
what?
carry capital C.
This operation?
Yes, this operation of reversing the arguments. Capital C.
Well, tough luck.
Yeah.
I mean, I didn't know that, and I'm sorry. I consider myself respectably educated here.
I find it too obscure.
Yeah. Okay, Sandra on a live stream has just written a piece of code, which I'm going to reproduce here. And then, okay, that's a different line. Okay, that's the definition of oops. That's the definition of reversed. Okay, now. Yeah, right. Agreed. That's what it does.
Mm-hmm.
Actually, you don't need the sequence. Just that p at that.
Yeah, p at that. Yeah, I mean, what's interesting about this is that we could advertise reversed as an alternative to curry, as a less obscure name for the operation of sort of initial curry, so to speak. See what I'm saying?
Yep.
We might have designed curry differently if we knew we were having this, because we could have then done curry as the forward curry, so to speak, rather than the reversing curry. But I don't think that's disastrous.
And carry is still experimental.
Is it?
Yes.
Well, then let's look back at what we did for curry, because it could be that reversed becomes this operation of swapping. I don't know if that's a good idea, because it may be that curry has other. Okay, that's a separate thing to discuss. That. All right.
It doesn't generalize to more arguments, right?
No, but reversed here can be literally all the arguments, right? And we could have reversed take a second argument, which is some kind of take spec or a permutation to say exactly what to reverse. I don't know if that's useful. I mean, it seems like maybe it's overkill.
I think we would have carry in general to do that.
Fine. All right. Well, this sounds good to me. This is kind of cool, actually. So then this is the form that we would do for sort by. And for sort, it would just say sort of list, comma, reversed of order.
Correct.
Okay, so just to be clear, what happens to what we have for sorted entity class? Right now is function or property goes to a string that's ascending or descending, but the order idea doesn't really apply.
For what? What are we talking about now?
Sorted entity class.
We could support ascending and descending as equivalent to order and reverse order.
I agree.
As strings?
Yeah, that's what I think we should do.
Okay, so this stays the way it is.
I think so. I mean, we could support reverse of order and reversed of order and order also in sorted entity class if we wanted to, but primarily there are only those two possibilities.
Yeah, but I think it's kind of dangerous because it might give people the idea that the order that they're going to get in SQL is the same as lexicographic order in Mathematica, which is not the case.
What is the order?
I mean, it might even be backend dependent. It depends on, if you have strings, it depends on how they're declared in the schema, because if it's alphabetical, then you need to define a collation. So it's very complicated. I don't think we want to go in documenting the quirks of different backends.
Okay.
You get what you get. In many cases, it's going to be reasonable, but not the same with us.
So which orders do you support here, Carlo?
Just ascending and descending. No, orders, none. We just support ascending and descending, and then whatever the backend deems appropriate for that for that column. Yeah.
Sandra on our live stream is commenting that reversed sounds like a very general thing, but I think it's the only name that isn't going to be obscure. I mean, yeah. My only question is whether the ending of that word could be anything different. Did you get what I'm saying?
Yes.
You mean like reversal?
That's what I just typed here, yes.
Oh, my eyes aren't quite what they ought to be.
I like the fact that it is a single word. Because
I think it's very good that it's a single word.
Yeah.
It has to be reverse something or other.
Mm-hmm. Because reverse function is too long here.
Yeah. I think reverse is the winner. Yeah, go ahead.
Yrook.
What?
It's a joke. It's the reverse of curry.
Yeah, okay, good. And we'll skip curry C along with some random combinator that somebody put in. I mean, this is a this could be thought of as a combinator of some kind. And in fact, this might even be, is this the S combinator?
I don't remember.
I don't remember either. Anyway, but we're not going to call it combinator S. That would be just unbelievably obscure. Okay, this sounds good to me. Let's go ahead with this.
Do we decide on tie breaking? Sorry for...
You guys think about that, okay?
Okay.
All right, on to the next item. Details of integer name.
Can I go away?
Yep, thank you very much.
Bye-bye.
Bye.
So we have Francisco to discuss this.
Okay. And what do we get? I mean, we've also now got Babylonian and things, right? I mean, we've also got in the function repository, and I don't know if you've seen this. This is for this other project, for our Museum of Math project. We are getting. Let's see if I can pull it up.
Ancient number representation?
No, I was looking for the interactive thing.
Oh, it's in your Dropbox.
Yeah, I'm looking at interactive number systems, and then what? Where is it? Which one of these is it?
The last one has everything.
Okay. All right. So this is all kinds of, oh my gosh, we've added all kinds of crazy things. We're going to have wait a minute. Where's the interactive version? Oh, is that it?
Yes.
So I have to evaluate this. Well, that's not going very far, is it? Okay, well, anyway, so you see all these different things, right? Which include let's see. Ancient numerals, you're saying, as the function repository?
Ancient number representation.
Oh, for goodness sake. This is such a bad search thing. We got to fix that. Could you report that as yet another search problem?
Yep.
Okay. Well, this probably should be a separate notebook. Okay, so here. Okay, so is this an integer name or is this not an integer name? The thing we're about to get out, if it'll load. Why
That
isn't it?
might be an integer
Your
string, maybe.
notebook is running still.
What's that?
The notebook in the background still running.
Okay, well, hopefully this will come through in a minute. Anyway, so there are many things here. Now, of course, okay, unfortunately, I don't think that's a string because it's got, I mean, certainly it's a graphic here, but even in Unicode, right, this is going to be a bunch of things, you know, all on top of each other and so on, right?
Well, the problem, right? The problem with this very old, maybe ancient numeric systems is that probably they don't have any character to represent them.
No, I mean, well, I mean, I don't know in Unicode whether, I mean, this is in base 60, so I can't really read this number off immediately, but I don't know whether this thing here is a glyph or whether this is 9 glyphs. Do you get what I'm saying?
Yeah, that will make it harder, even if it's present. That's right.
Right, but even in the Roman numeral system, okay, so we've got the following issue. If I say Roman numeral of, you know, some big number, okay, even bigger number, right, there's that bar thing that starts happening. Okay. Am I making sense? So, you know, what is integer name? What is its contract for what it returns? I don't think it always has to return a string, does it?
No. So there is a difference. We have integer name and we have integer string. That's right. And the idea is that integer string returns a numeric representation given.
Returns a what?
In a numeric system, returns the string. That's the idea of integer string versus integer name, which returns the full words in a given language. So probably this
I see what you're
Babylonian.
saying. Integer string is closer to what's happening here. But I mean, if I say integer string of this number, comma Roman, what the heck is that? What is
Because
that?
that's actually string boxes.
Oh, for goodness sake.
Yeah, that's an old design. And also we have Roman variant. You can try that, which uses the Unicodes for these larger Roman values with integer string.
What? What's that?
So those are actually the Unicode codes for large Roman values.
What do you mean they're the Unicode codes? Well, they don't look anything like them.
Yes, it's documented that that existed. So
I'm sorry,
So
what's
that was
document? You're claiming this is what they used for that. Is that what you're saying?
yes, that was a variant of used at some point. Yes.
By Romulus himself, no doubt. I mean, I don't know. Where did this come from? I mean, maybe it was taught by the wolf. Never mind. I'm just being ridiculous. Okay. Well, I never heard of that. I never knew that. I never knew that existed. Huh. Well, that's cool. All right. I had no idea. What is that thing? I mean, is that a, let me see.
Can you try something even larger to see how much this goes?
Yeah, I mean, this is pretty weird what this says on the. That's really weird. Okay, let's go larger. Let's watch the thing blow itself up. Okay, that's an amusing problem. It reminds me of transfinite numbers where you're naming, whereas you go to the limit, omega to the omega to the omega, whatever, you get to epsilon 0, then you limit those, and you always have to keep generating new names. And so so this, when you run out of names, it's because the Unicode characters are missing. Never mind. I'm just sorry. I'm just having my little humor moment here for the okay.
Also, I did send a link of.
Right. Oh, let me see. Sandra is sending. This is probably going to be horrifying. Well, that should be fixed. Right. Okay, but anyway, so basically, you're saying up to 100,000, there are characters.
So I don't know if this other numerical system that doesn't have any string representation should be included in integer string or in a different function to generate graphics with this numeric system.
Yeah, I mean, look, by the time we're doing this, we're also, I mean, this is for now a function repository kind of thing. I think we need to understand, I mean, cuneiform is not on plane 0 in Unicode, right? So I don't know what the glyph system is for that. So we need to look that up. And clearly we can do this with boxes, but it's pretty grotesque. I mean, with string embedded boxes.
So looking at the code that Eric has, it looks like he's drawing graphics like lines.
He is, because that's because we can't render that Unicode in all platforms yet. We will be able to soon. We can render it on some platforms because it's it's just complicated to deal with that. I don't know where. Let's see. If we say I don't know. I just don't remember that there are code points for these things.
Yeah, Daniel sent me a link to that, which it seems they have added all that to Unicode, the full.
Yeah, they have. But I'm asking you the question: have they added? This is totally freaking weird. Okay, so Akkadian, right? The Akkadian Empire, all good. Okay, cool that we have that. But look at this. Why is there periodic interest in the Akkadian Empire?
Maybe that's related to academic semesters for school.
It has to be. It has to be that there are, people studying it at a particular stage, or maybe there's some country, maybe in the French school system where everything is mapped to the day they study the Akkadians on a particular day of the year. We have an irrelevant question on the live stream from Ethan asking, when are we going to have meetings on NetTrain? I have no idea, but I know those are. I guess we're not live streaming some of those. We do have machine learning meetings, and we could. Okay, the responding to our audience, Sushma, maybe you could find out whether the agendas are interesting enough to live stream for some of the upcoming machine learning meetings.
Yep.
Sometimes those are really not exciting. No, they're exciting, but in different ways. They're mostly about internal resource allocation. Okay, so what is the question here?
Well, the question was actually a bit different. It was about integer name, the fact that there was a suggestion from Eric Weinstein about changing our default value for the second argument is digits words, which change from below 1000, it's the full name, but after 1000, it becomes numbers, 3-digit blocks, and then only 1,000, million, billion, etc.
I'm sorry, what is the, I mean, right now, if I say integer name of something like this, I get that, right?
Right. So if it was somehow inconsistent with the low numbers.
No, that's the automatic setting. Look, if I want this, I think this is actually pretty good behavior. And I think that, having something where there's a crossover from one to the other is reasonable. What are the yeah, what's wrong with this? I don't understand what's wrong with this. What's wrong with this? Explain the problem. I don't see a problem. What's wrong?
Right. He wanted words to be the default.
I don't care. It's not. No, it's not happening. This is a non-experimental function. We chose it well. It's done.
Okay. The other inconsistency we still have, which is more a development issue, is that for other languages, the default is actually words always.
Well, then it's wrong.
Because we don't have yet the digits words for other languages.
Okay, then we should get that.
Yep, that's in progress.
Okay, and that's no good, right? But I mean, clearly we can fix that by and you probably know if that's correct. I do not. But yeah, okay, fine. So I mean, we got to fix that. Also, the fact that it blows the top off when it's too big a number for something like Spanish.
Right. For other languages, we still have a limit, which we don't have for English. That's right. That's something we need to extend.
Okay, fine. I mean, it seems like a good intern project for somebody, or possibly our data curation team. Okay, to go through and essentially make the template for that, because I think they're all going to be, since in the modern world, actually, the modern world, I think everybody's decimal for these kinds of numbers. And we don't have to have for the weird ordinal cases and things. We're not going to have we're not going to have the quadrillionth, the 3 quadrillion 200 and blah 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 blah. We don't care about that. See what I'm saying?
Right. That's not even supported yet for English. That's right.
Right. Okay, but so that's thing number one. Thing number two is the ancient number systems. Okay, and what we're going to do with those. And I don't even know. Okay, so for example, does Latin work right now? Do you know?
No, that's not.
Does not work? I think we should get that to work. It's rather straightforward, and it's something that people, let's get that to work. I mean, it's a simple algorithm. Makes sense? And it's educationally relevant. And I guess, what do we do with if we say integer name? Oh, I see. We just have language here, whereas integer string has different kinds of, integers. That's right. As opposed to integer name, which has to have a human language. Make sense?
Right. So the idea of integer name is that it's a full name in some language with different variants, of course.
Right.
For example, ordinal, cardinal.
Fine. I mean, it could be the case. I don't really know whether, in Akkadian, maybe the name of the number was the same as the writing of the number itself. I have no idea.
That's indeed a case we already have for some Oriental languages. So in Chinese, it's the same, the word and the actual number.
Okay, fine. Okay.
Could it be that the ancient case is more like a form? And then we allow ourselves to use any type of typesetting? Like base form. I'm thinking of base form and things like that.
Where we say integer, it's pretty weird to have 3 of these: integer string, integer name, integer form.
Well, not necessarily integer. It's some sort, I mean, were they able to handle fractions or something like that?
Yes, often in weird ways. Well, are you seriously imagining, I mean, we could imagine, this is pretty wild, that number form somehow has, that's really wild.
Well, let's say ancient number form with a second argument.
Are they always ancient?
It will be more a generic numerical form than ancient necessarily. So that we could support also Roman, etc. I'm not sure we consider that ancient.
Well, the other thing, which we don't support right now, is the Unicode symbols for like 3/4. Right, there is a distinct Unicode symbol for 3/4, but we don't use it. Am I making sense?
Yep.
All right, let's put this on the agenda again. I'm trying to think here whether I mean, an integer string, we kind of cooked our goose on that one by calling it string. But then that's actually what we wanted there, because that is typically a string. All right, to be continued. I mean, I think Eric is putting those ancient number things into the function repository. Let's see what pathologies there are in those before we start worrying more about this. Make sense?
Yeah, okay.
Okay. I had no idea that there was that symbol for 10,000. Fascinating. Okay, question about FoldWhile list. The termination of FoldWhile list. Okay, didn't we discuss this last time?
We started discussing it, but you said this required more thought. Okay. Because here we have an important precedent from NestWhile, and well, we are not sure whether it's good enough. So the problem is...
I was going through my archive materials. I found a note from 1989 which listed take_while as a function to implement. So I'm glad we finally did it. Okay, so what's the issue here?
The issue is that NestWhile and the current implementation of FoldWhile show the last failure, so the first failure as last element. While, for example, take_while only takes valid elements.
And while itself does what?
Well, while doesn't return a result, and
it doesn't do that. The first case time that the test fails, it's out of there.
Exactly, and it doesn't do anything later.
Yeah, it's repeat until we'll do the first failure case. Well, it depends on how the while is set up. Some languages have a do while. So you do action while whatever, and others it's while whatever do. And so then the one you have the first failure case and the other you don't.
Okay, so wait a minute. So the main issue here is that we are inconsistent between NestWhile and background noise, NestWhile and take_while, right? That's the issue. Take while does not include the failing case. Nest while does include the failing case. And the reason for that is that nest while list, if it doesn't include the failing case, then it has to have essentially a negative length list if it failed in the first instance. Is that right? Or am I confused there?
Wouldn't it just be an empty list?
Now I'm wondering why it isn't an empty list. What does nest while return if it fails in the first case?
Exactly.
I think it returns an error condition.
Yeah.
Which it could. Background noise, guys. Did we get nest while wrong?
Probably.
My gosh, it's been with us since 1999. Until the result is no longer positive. So nest while that's even, and then return the first failing case. I mean, what's really kind of annoying is that there's no way to monkey it with its later arguments to determine. By the way, there's a bunch of weird, like, seashell background noise. Can we try to get rid of that, please? Oh, disappeared. Amazing. Okay. So the issue right now is for FoldWhile. By the way, I don't understand what happens at things like map while. I mean, we could imagine a map while as well, couldn't we?
Yes, I think so. It will be map over the take while, I guess.
No, because it would leave later elements unmapped, so to speak. See what I'm saying?
I see, yeah.
So, I mean, if I said map while F I don't even know whether it's a precondition or a postcondition. See what I'm saying? That. So then that would return f of 1, f of 2, boring, 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 f of 5, and then probably 6, 7, 8, 9, 10. Right? Although I don't completely know whether it's I mean, that would not return. That would be crazy to have an f of 6 in there.
Yes, yes. So this would be like take while. Yeah.
Now, an alternative would be a headdress wrapper type thing around the f that says, and I'm just wondering whether there's a headdressing approach to doing some of these other whiles as well, because I mean, what we could imagine is a headdress that basically says, well, it's ultimately if hash is less than 6, ampersand f, otherwise identity.
I think you want the hash at, yeah.
What did I do wrong here?
I think you don't need the hash inside.
What do you mean? I don't need this?
Yes.
Oh, you're right. But then I need, yeah, okay. That's wrong. This is wrong. This is wrong. I need this there, right? That's correct now. What is that thing there? I mean, that's like a conditional expression type thing. Well, anyway, okay, but back to the FoldWhile case. I'm a little concerned that we might, while everything. Although clearly nest while, okay, so nest while is clearly applied to the result. Map while in this formulation is being applied to the input, not to the result. Making sense?
Yes, but in that sense, it's like take while.
But take while has no result other than the actual elements themselves.
Yes.
All right, so back to this. I mean, okay, what is the question here?
My impression is that we cannot change FoldWhile. Sorry, nest while. It has been there for too long. So the question is whether we respect the precedent or we move away from it.
Yeah, it's the
the strongest point of the current precedent is that we can return always something, because even if the seed element is wrong already, we still can return it.
Is FoldWhile useful with this returning the first failure case? I mean, clearly FoldWhile list, you could just say most of it if you didn't want the failure case. But FoldWhile itself may be kind of useless. I don't know. What are some good examples of FoldWhile? Let's come up with a few examples of FoldWhile, okay?
Mm-hmm.
And then let's Danny, you were creating background noise.
By moving my mouse? I don't think so.
Okay, all right, fine. Then it isn't you. Okay, well, whoever it was now went on mute. All right, so I think that's the place to go next, is let's generate some examples. Okay, let's see how disastrous it is for FoldWhile to return the failing element, failing case. Make sense? Or we may discover that's actually what we want it to return.
Okay.
Okay. I mean, I think FoldWhile. So, an example of a use of it would be some kind of transducing, one of those Mealy machine thingies. What are they called? A finite automaton where you're reading symbols in and you're walking around the finite automaton. Okay. And then what this is saying is you reach, let's say you're trying to do parsing. You reach a thing that doesn't work. Do you want the last thing that worked? I kind of think in that case you want the thing that doesn't work. I think that's a case where you want the symbol that was off the end of the parse. So that's an argument for returning the first failing case. let's do some examples of this. Fair?
Yep. Okay.
Okay, let's try and do one or two more of these.
So
Okay.
can we look at the operator forms part?
This here?
So the previous part in fold, we were comparing the syntax of the operator form of fold with the operator form of FoldWhile. So we just wanted to check with you that you are okay with this, because in fold we introduced this two arcs form.
Yes. Well, here it will be a 3-argument form, right? The minimum case is that second thing you're giving there, the 3-argument form with the list and the criterion.
Exactly. Yeah. So the main question is whether we want that too.
That case, I would think we do. But if we go down to 2 arguments,
no, two wouldn't be possible in FoldWhile.
well, it is in the operator form there.
Exactly. Yes. Yes. Because in general, operator forms are most useful when they take a single argument in the second pair of brackets.
Yeah, I understand, which is why we want the 3-argument form of FoldWhile, which goes to a 2+1 argument form in the operator case.
Exactly.
Okay, sounds good to me.
Okay. So here we have 2 corner cases, and we just want to check with you that you are okay. In this case, I'm very much convinced. I'm suggesting the right thing.
That it should be f of no arguments.
Exactly, rather than an empty list.
Okay, so there's 1 layer of list here. There's 2 layers of lists there. Yeah, there should be 0 layers of lists in that case. I agree.
And no arguments.
Yep.
Yeah. And we have precedents already of this behavior.
Oh, that's interesting. Constructive F. Yeah, it makes sense. Okay. Okay, so what are you suggesting that the array of F operator form should be? It's just literally the first argument, and then the second argument ends up being the payload of the operator form.
Correct, like map and map thread and all the apply something from the left functions.
Seems okay to me.
Okay, so we will implement those 2 changes.
Yep. What about the case of array of F of 2 arguments?
What do you mean?
This form here. Array of F of 2, 2, 3 should work. Right. That's the operator form of array of F, 2, 2, 3. Right?
Yeah, we can support that. Yeah.
I mean, it's a minor corner case, but I think we might as well support it. Okay.
Danny, do we do that with other functions, supporting 2 arguments in the second pair of brackets?
In the second pair of brackets, I believe we do.
Mm-hmm.
I'm fairly sure. I think some of them, I don't know, we may even allow options. Well, okay. I'm not positive on that one, but.
Sandra on our live stream is pointing to drop while. Oh, which doesn't exist. Oh, but it's in the function repository. Right. And drop while, what does it do? What does it do? What is it? Does it have? So wait a minute. Take while takes nothing that violates the criterion, right?
Yes.
What does drop while do?
I think it would drop all that violate, no, all that obey the criterion.
Right, leaving only those things which are leaving the first thing that doesn't obey the criterion. Okay.
So sorry. So this is a bit more difficult discussion. So the idea is that transpose with a vector has always failed. However, it might be made to work by supporting this default, the fact that the list one returns a vector. The idea is that many people...
So you're saying that transpose of ABC should return ABC?
Yeah. Because then that would help people who write these combinations of transpose vector dot matrix dot vector.
I see. Seems reasonable to me. I mean, you're saying that transpose, the definition of transpose is that it interchanges, so it's doing a permutation on the tensor indices, right?
Right.
Okay, so in this particular case, there is only one tensor index, so the only thing it could possibly do is leave it the same.
Exactly. Yeah. So the documentation could not say now by default it transposes the first two levels. It would have to say something slightly more complicated, but it would become more useful.
I think it's fine. I mean, in terms of it could say transpose the first two levels of a list that is of depth 2 or more. And then it could break out the other case.
Right. And yeah, so I've asked other people like Rob Knapp and Roger, and they are okay with this change.
I think it's a good change.
Yeah, I think for at least for typesetting some operations, it's going to become useful.
Right. Okay. Position largest.
Yeah, so Danny, can you explain here?
He's on mute.
Sorry, I was on mute. Okay, so the specs that I've seen for this, did not leave me clear on what it is that we're supposed to implement.
Okay, I don't think we're going to get to that. We've only got 4 minutes here, so I think let's cover this another time.
Okay.
Our live stream is asking, how do we represent column vectors? We don't need to. That is the whole beauty of the way that we do our tensor manipulation. Go on, please, because we don't need to distinguish covectors from vectors at this stage. We need to distinguish covectors only when we're doing, well, Jose, you can perhaps say what the criteria, when we have to do that.
Right. So the traditional idea of using vectors and covectors is just a notational device to explain how to do these multiplications, the dot multiplication. But then it's also used sometimes to express the true difference between vectors and covectors in physics. Like, I don't know,
but that only shows up in wait a minute, what?
It shows up in any situation in which you have a metric which is not 1, 1, 1, 1.
Right.
And that can be.
Why does it show up in the momentum? Wait a minute, that's not correct. The momentum, I'm confused there.
Yes. So, for example, imagine all these Lagrangians that have PAXA. So P, what we would call P dot X.
Yeah.
Right. So, in order to support that with any type of coordinates, curved coordinates, polar, etc., you have to make the x's or the x dot always vectors, and the p are covectors.
How are we dealing with that in curved coordinate systems?
We are not right now. So when we have coordinate chart data, we are using always frames that are orthonormalized, even if they come from polar coordinates. So precisely to avoid this distinction of vectors and covectors.
Wait a minute. So isn't there a theta hat and an r hat in polar coordinates where one of them, those happen to be orthogonal, but is that always the case?
Well, there are the so-called coordinate vector basis vectors, coordinate basis vectors, and those are not orthonormal. In polar coordinates, for example, they are not normal. I mean, the coordinate theta vector has length r. As you get farther and farther away, it's longer and longer. And that's why you normalize them, and then you have orthonormal vectors.
I see.
So that's why the metric in the coordinate metric in polar coordinates has the diagonal 1r squared, meaning the theta coordinated vector becomes longer and longer with r.
I see. So by having orthonormal basis vectors, we avoid the problem. We avoid the need to have covectors.
Exactly. But if you want to do computations with coordinated vectors in which you don't orthonormalize, then the metric is non-trivial, and it is super important to keep track of whether you have vectors or covectors.
By the way, what has happened, and this is my last question here, well, what has happened to the effort, the Oleg effort, the long awaited Oleg effort to get us more coordinate systems and so on?
Well, I think it's just in back burner. He collected many of them, and we have here the fundamental, I think, 11 coordinate systems.
But this orthonormalization idea, that can work for any coordinate system, is that true?
It can work, yes, for any of them. But these special coordinate systems have special properties, like the Laplacian is particularly separable and things like that. So not all coordinate systems will have as nice properties as these have. So
is it the case? Okay, my one physics minute. This orthonormal basis thingy, is that doable in all the random coordinate systems in general relativity, or are there cases where there's singularities in those?
No, orthonormalization. Well, let's see. So in gravity, we have something similar, which is the so-called VLVI. You know, this orthonormal. Yes, we use the German word, the
Vierbein?
Vierbein, exactly. Sorry, I had forgotten. Exactly. So we can always select an orthonormal.
That's a good explanation of what Vierbeins are, right? That's a better explanation than I knew before. Okay, fine.
Yeah,
yes.
but there is still some hidden, I mean, you are moving the complexity of the curvature somewhere. So all these coordinate systems are coordinate systems in the Euclidean space. So the metric in the end is trivial. In general relativity, you move the complication somewhere else. Because this non-triviality of the metric is the curvature, and that cannot be eliminated.
But so in the Vierbein formalism, you're saying those are orthonormal basis vectors, and then what happens? Then I mean, what would normally be just my curiosity? Then what happens to is there some? I mean, there's just a metric. Is there only the metric, or is there some other object?
So exactly. So you choose a metric which is now 1, 1, 1, say, or -1, 1, 1, 1, if we were in relativity, but you still have to keep the curvature somewhere else, because the curvature cannot go away by a change of coordinates. So yeah, so you are using vectors that now will, for example, they will have non-trivial commutators.
Oh, right? That's horrifying. Yeah.
Okay. And so the commutators will be non-trivial, and those
with respect to what? With you mean when you do parallel transport of one vector to another?
Exactly. They will not close. If you do the typical square of going first one, then the other one, it will not close. While here in the Euclidean space, it always closes. These commutators are all trivial. Yeah. So you get this epsilon with 3 indices, which is non-trivial, and that contains effectively the same information as the Christoffels, which came from the metric. So as I said, in relativity, you are moving away. You are moving the non-triviality from one place to another, but it's always there.
Fair enough. Okay. Well, all right. Good. Fascinating. Okay. I think that's okay. That's it. We ran out of time. Continue next time. All right. Thanks all. Thanks to folks on the live stream. See you all later.